be accessed by multiple users or various users in the execution. So in this case, we understand that now the presentation of data that we have been replicated in different levels of variables that we have. So at this case, we can now understand that we are able now to store millions of data or millions of data presentations because of these pointers, because we can be able to point an address of another variable, and each and every one can be able to access those data at a given point. So today I wanted us to start with the functions, and maybe before we start on function, I'm sorry for the last class. I had issues with the internet, and that's why I did not continue with the class. But today, maybe you can first of all critique, or maybe you can ask questions on what we covered last time. Maybe if there is a question before we proceed to functions, maybe you can ask a question. So let me start with Rachel. Rachel, do you have any question on pointers? Peter, do you have any question on pointers? Maybe can we proceed? Okay. So Rachel, do you have any question? Rachel, do you have any question? Felix, do you have any question? I'm asking a question on the last topic that we discussed. Maybe if you have a question before we proceed, maybe I can answer the question. So because of time, maybe we can proceed, because I wonder whether Rachel can hear me. Rachel, can you hear me? Then we have Hashim. I think Hashim, you have joined. And do you have any question on a previous class that we had? Hashim, I still have seen you have joined. If there is a question on pointers on the last class that we discussed, maybe you can ask a question. Then we can proceed with function, because that is where we are supposed to start today. So can I proceed? Can I proceed? So can you have a response, please? So can I proceed to functions? Hey, my friend, I am waiting for a response. I can't continue if I am not sure whether you are listening or maybe we are together. Okay, so I think we can start from functions. And if you look at now functions, we always say that these are groups of data or groups of elements that are supposed to be executed maybe using a certain programming language. But in this case, we'll be looking at now which are these groups of data that we have. And within function, let me use PowerPoint to explain that. In a function, we always understand that we have to come up with what you call the inbuilt functions. We have the inbuilt functions and we have the user-defined function. So these functions that we are calling the built-in functions, and the other one is user-defined functions. So in this case, we understand that these are all groups. So we have groups of inbuilt functions, and we have other for user-defined functions. But if you understand about functions, it's like now we are saying, let us bring together all the execution, You bring together all the executions. But now we are grouping them, and maybe we call them, we give them a name. Maybe we can give them a name. So you find that when you're using a function, it is easy to retrieve anything that you are retrieving because everything has been grouped in one area. It is still easy to understand because now the moment you are having these elements and we want to execute them, you'll be able to understand them easily because I'm looking at where I can have the module 1 and this module 1 is supposed to do, or maybe we can have addition, then we can have subtraction, then we can have division. All these are functions or procedures or methods. But if you have and, if I am using C programming language, if I have this as add, and this one I have it as subtraction, and the other one that I have it like division. All these are independent functions. These are independent functions. And these independent functions, if this one fails, this one will not be affected. If that one fails, it will not be affected. All these will not be affected. So you're not doing away with coding. So we can reuse. So another way that we can say, we can do what you call reuse. Reuse code. We can reuse code. And when you reuse code, it becomes easier for you to execute all the statements that you require at that given time. So if I can go back to my notes, in this case, we can try to understand that when you're using the functions, some group of statements that together perform a task. But which is that task? I think I have explained that task. It is addition. It is subtraction. It is division. Right now, I know if you look at in coding, we have a function called printf function. Now, in C programming, we cannot use a statement without printf function. We can't if you want to have an output. So the whole of this becomes a built-in function, or sometimes we call it inbuilt function. And the moment we call it an inbuilt functions, it's because we have a defined library. There are defined libraries that are used in these executions. So you cannot bypass this. You must use these executions or these libraries. At the moment we use these libraries, we are now able to use different forms of executions. So that's why we understand that every C program has at least one function. And this function is the main function. What is the function of a main function? What is the role of a main function? To execute the statements, to execute the program that you write. Remember, when you write a program, if we fail to use a main function, this program will never execute. You can divide up your code into separate functions. So I think I have explained this, and that's why we are saying we separate it to the first function. Then the next one, this one you can separate it into a given function. The other one, you separate it into another given function. So you find that now, at a given point, we are looking at now different executions. So here we have two executions. And these executions are able now to perform different functions that we have. So that's why we are saying we separate it into different functions in a code. When you define how you divide up your code among different functions is up to you. So it's up to you. So that is when you are using what you call the user-defined function. So let us try to understand before we come to this definition, because we have to understand that there are two main terms that we have to use in functions. And one main term that you're supposed to use in function is what you call the function declaration and the function definition. The function declaration tells the compiler about the function name, return type, and parameters. I will still come back to this when I will be defining what you call the user-defined function. It provides the actual body of the function. So it means if you are having this statement, let me use this function, the first function that I have here. And we are now referring it to a function x. So this is now a function that we are having. So this function that we are calling and maybe I can introduce these functions so that you'll be able to see it's a function. So if you are working with this function, and we need to understand the definition. So the whole of this becomes the function definition. So this body, where we write this statement, maybe we write return something or that is where we have a function. But inside here, where we have some parameters inside, because here we have some parameters. So where we have some parameters, the whole of this, we call it a function declaration. So this function declaration, it has what you call the syntax or the signature. So you can say it defines the signature of a program. And when it defines the signature of a program, what we are looking at is we are looking at the function name and the parameter lists that we have. So parameters are the variables to be passed to the main function. Variables to be passed to the main function or to the actual parameter. So the whole of this, and because we are using a function, this now forms what you call the formal parameters. The formal parameter. So the whole of these are formal parameters. But these formal parameters are the ones that will be passed. So the main function is to be passed to actual parameters. And these actual parameters that we are having, they are within the main function where we call them. We will be able to see them the moment we'll be looking at the inbuilt functions. So that is why we are saying the function declaration tells the compiler about the function name, the return type, and the parameter. So the whole of this, here maybe we can have the return type, maybe int, and then we have the formal parameters. Then you close the bracket. All this forms what you call the function declaration. But now the signature doesn't come from the type. It comes from this point. So when the signature is coming from that point, now we are calling it. We are calling it the signature. When you're moving from the function name to the argument, that becomes the signature. So I will not try to explain this. I will still come and explain this. The moment we'll be looking at what you call string functions. So in this course, we will be looking at string functions because there are many string functions that we can use. And one of the string functions that we can use in the definition is what you call the str cut mem cpy or cpy. We can use others like len. Len is the length, so we can use cpy. Maybe we can use stl cut, str on. That is concatenation. Maybe if you want to combine two strings, you can use what you call the concatenation. But let's try to understand another name for this function. And I think I have explained this. I've said it is a method or a procedure, or it can be a subroutine. So when you say it is a subroutine, now we define in another way and we say it's still a function because we are representing different. So this function has two main categories. And one of them is the library function. And these are the ones that we are calling inbuilt functions. Inbuilt functions. And one of the inbuilt functions that we can have is what you call the SQRT. SQRT. Then we have another one which is floor. We have scale. Remember, when you're using floor, we are now displaying the number which is the smallest from the actual number. So if you have the number like now, if this number is having 19.5, the smallest number from this is 19. That is 18. So it will give you 18. But now if you're using cell, that is the highest number from the decimal point. So this becomes 20. So for the floor, it can give you 19 or 18, but mostly we can say it is 19. But for the cell, it can be 20. Then the next one that we can use, maybe we can use cosine. If you want to get the cosine of a given number, we get the tan of a given number, because this function has already been created by the manufacturer or the programmer, and they have been used within the program. So without using these, the moment we are using these functions, and we want to get the square root of a given function, of a given number. Like now, maybe I can say, I want to get the square root. Maybe I want to get, if I have int a, and maybe that I say SQRT, but I get the value of a. So it means if a now, suppose a is equals to 4. Suppose a is equals to 4. So the square root will be 2. The square root will be 2. So that is now, we are using a function that was created within the structure of a C program. And for you to use these functions that uses the inbuilt functions, we must use the math library. The math library, meaning we use hash include, then you say math.h. Math.h. So it means this math.h is the one that has now all these libraries that we have here, and which are mostly used as a statistical functions. And within these functions, if you fail to use these within the preprocessor directive, automatically this program cannot execute. So we must use math.h if you are using all these libraries that we have here. Some of them, because these are some. We have others that we have. In user-defined function, this is where it allows user to define his or her function. You allow the user to define his or her function. I want to code a program using one of these functions. Maybe I use square root. And I want to use an editor. I don't know whether this editor is still functional. Maybe I can use this editor. Allow me to use this editor that I have here. And I hope you can see this editor that I'm having here, the online editor. Can you see? So if you can't see, please, you can tell me so that maybe we can look at now how we can be able to change this. Can you see it? So hope I'm clear. So please, am I clear? So can you see the interface that I had already displayed here, the online? This one? Can you see it? Yes, Grace, I can see you are typing. Huh? Yes. Okay, so I think we can write a program. I will still use this program. I want to do away with this first. And I want to declare a variable called int num. Int num. And with this int num, I want to assign maybe num is equals to 16 or maybe 500. 500. Then within this, I now need to get the square root of this value. So I can say printf. So I say percentage %d, percentage %d. Then here, I now get the square root sqrt of a function called num. For a function called num. So if I try to run this program will have some errors. Program finished without exit code. Okay, so we need maybe to create a library here. Maybe we have hash include. Remember, we said we must use math.h. Math.h. So let me try to execute this program. Program finished without exit code 0. Please enter to console. Just a minute, just a minute. Command line 1. So let me see. Just a minute. So if you look at this program, I don't know why. Just a minute. Let me see. Maybe why is it giving me that long statement? This one is giving me a memory. I don't know why it is giving me a memory. I don't know why it's giving me a memory. Maybe we can say exit. Exit. For the case of that, maybe I can try to look at why do we have these errors in that. Implicit declaration. Okay, I'll first of all try to see whether maybe I'm using some different interpretation on this. Just a minute. Hello world. So this one is able to give you. Okay, let me try to see whether maybe we have printf. Maybe we can have another variable here. We declare it as a result. And then within here, we can say printf %d, %d. Then here, we are supposed to get a result. But we need now to get this result, and we say result is equals to sqrt, and this is sqrt of n, so which is now a function that has to be defined. So I want to execute this program without math.h. We see what will be an output. Still is able to give me 3. So I think this one can be able to interpret it, but it is always prudent if you are using that. We use hash include. That is math.h. 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 So it still give you 3, but because this math.h was an inbuilt function that was invented in C programming or in C compiler, maybe I can say that is why it is still executing even if I have not included it. But in most cases, when you're using this, because still I can be able to get the cosine of that. And that's why we need still to make sure that we can be able to have this math.h so that it will be able to get the actual value. So if you look at the cosine of this, and if you want to go to the anti-logarithm and you get the cosine of 9, it is 0. So you'll be able to get the values that we are supposed to get using this code. And that's why we are saying this now becomes the inbuilt function or the user-defined function, or the inbuilt function, sorry. If I want still to change this code, and maybe I use floor. Let me say maybe I use floor. Let's see the output that is supposed to give you. It's giving you 9. Let's say maybe I use cell as a function. We see what's supposed to give us, still supposed to give 9. Suppose I want to change this, and I want to call it float. Then here I change it to f. And here I have 9.8. 9.8. Let's try to run this execution using cell. So the answer that is given is 10. So if you look at a cell, we are giving the highest number from the initialized value that we had. Suppose we use floor and we try to execute this program. It is giving 9. Now, I think you can see the difference between cell and floor. So if I ask a question on a cell of this, I can still try to get maybe 0.3. Maybe you can say it's rounding off. We see the output. So this one gives you the smallest value, but this one for the cell gives you the highest value. It gives you the highest value. And we can see the highest value given that. So the highest value of 9 is 10. And the lowest value of 9 is still 9. 9.3, sorry, is 9. And this, suppose we change this and we remove like that. Let's try to use same, because we have seen that we rate round it off. It is supposed to give you 9. And the same case, when you're using floor, it's still supposed to give you 9. So the moment you're using a decimal point, maybe you are using any decimal point, that is the time that is supposed to change the presentation. So I think for now we can define when you're using a same function is the highest, floor is the lowest. So that is why we understand that these inbuilt functions, they are supposed to be used in the program execution. So you can look at this structure, and what we have here is the function, predefined and user-defined. So library function, declaration in the header files, body inner. So all these are functions that you can use as a predefined function. But for the other one, we can use them here in the executions. Then after that, we can see that we have some benefits of these functions. And one function is to provide modularity. And when you talk about modularity, we are looking at now, maybe we can define this as sections or different structures that you are supposed to have within the sections. And that's why we find that it is very easy for you to code. It makes your code reusable. When you say reusable, we can reuse in various levels of executions. That is why we say it's reusable. In case of a large program with thousands of code lines, debugging, I think you know what is debugging. That is collection of errors, and editing becomes easier. So if you look at the presentation of this one becomes easier because you have your own data presentation. And then it makes the program more readable and easy to understand. And I think those ones are very easy for you to interpret on that. So what I want us to do is now to come up with what you call the user-defined functions. And when you're using what you call the user-defined functions, because that is now where we'll be looking at, we have talked about inbuilt function and we have already completed the inbuilt functions. So we always understand that we start with the type. Then we have what you call the function name. Function name. Let me use one word. Function name. Then from the function name, we have parameters. Parameters. So I can call parameter list. So parameter list are elements that are mostly used to do that. So then we can have that. So we have body of a function. Body of a function. Then from the body of a functions, we can now close that. We can close that. So in this case, in our own interpretation, we are saying, suppose we have a program that earns two values. So we have int and then we must use parameter, maybe int a, comma, int b. Then maybe we can introduce something like that. So in this case, we are saying, let's have two variables, but these two variables are supposed to add or supposed to subtract. So that is the case that we need to look at here. But before we go to that, we need to ask ourselves the interpretation of this is turn type. For the function return, do some annotation of these two values that we have. So in this case, we can be able to understand the coding that we are supposed to have in a program execution. And that's why we will be able to understand most of the executions that we have, they are able now to interpret different levels of executions. different levels of executions. So in this case, let's try to understand the coding. And we ask ourselves, how many categories of functions do we have? One, we have return type. We have a return. And the next one that we are supposed to have is what you call a no return. We have a return and a no return. Meaning, at the end of execution, this is not supposed to return anything. But at the end, it's supposed to return something. So we'll be looking at that. When you're using no return, suppose I want to use this as a no return, because this one was a return. This was a return. Suppose I want to use with a no return. Suppose I want to use with a no return. What I do, instead of using int, I use void. I use the keyword void. So void add. So it means inside here, we will not have any parameter. So we will have no return. No return. So in this case, we are looking at a point where the program that we are having here is not returning anything. So it's like you are saying printf hello. Printf hello. Printf hello. So in this case, we are not returning anything, but in this case, we have already returned a certain value. So please, can you allow me, please? I have an exam from 12. So please, will you allow me first of all to set this exam? Don't go away. Don't go, please. Because I have an exam that I am supposed to set so that it can start from 12. Then after that, we can proceed. Just give me 5 minutes. Am I around, please? So that you can first of all synthesize what we have already covered. Am I around, please? You can respond to that, please, before I move. So please, I am, okay, so I have gotten an answer from Onyango. Okay, I'm around. I have an example that ZTech University students are doing at this time. Mostly those that sit for ZTech exam. Please allow me to set the exam. Then after setting, I will come immediately. That is 5 minutes. So it is 11:47. So I'm expecting from 11:55. 11:55, I will be back. Please, don't move. We have Rachel, we have Peter, we have Onyango, we have Omodi, we have Maina, we have Hashim, Felix, and yes, there is one person who has gone, but I think you'll come back. So please give me 5 minutes. I do that, please. So I think now I have resumed back. So are we together now? I think we can continue now. Can we proceed? And I have seen some of you have gone. So can we proceed now? Can I proceed? Please. Can I proceed now? Okay. So I will proceed from where I had said we have two functions. We have two main categories of inbuilt functions. And one category of inbuilt function is the one that has a return type and the one that has no return. So when you have a function that has no return, so it means this function will execute. This function will execute, but return type should be void. So there are two ways of writing this. You can write and inside and we write void. It is still applicable. Meaning we don't have parameters, we don't have return type. So it's like now we are just printing the name. We are just printing the name. But for this case, where we have the return type here, it means we must have something to return. So we must use a keyword return what? We can return either A plus B. We can return either A plus B. And then we pass it to the main function. So in this portfolio, or in this case of program execution, so what we need to understand is that how will you write a program using an inbuilt function? And I want to use the same program for you to add two numbers. And when you're adding two numbers, I will be able to look at now, we first of all create what you call the function prototype. Now, in this case, when you are now including every program in the execution, we must use what you call function prototype. So function prototype is a function declaration that defines or tells the user that our compiler, tells the compiler that you expect a function called X. So I want to write this. So hash include, then we have standard input.h. And inside this where now we have int maybe, and I want to add two values. Int num1, or int a, comma, int b. There are two ways of writing this program. At the end, we must end with a semicolon. So the moment we end with a semicolon, this becomes what you call the function prototype. The function prototype. There are two ways of writing this. Int, we can write int, and then we have int, comma, int. Int, comma, int. Int, comma, int. So in this case, we are saying we have two values, but the first value is given. We will be giving it with a representation. So this is another way of writing that program. That is another way of writing that program. So the next thing that we are supposed to look at is now having what you call the main program. So we have the int main. So let me use that. So we have int main. Remember we said in C program, main is used for execution, and we introduce it. But when you're writing a user-defined function, what we need to understand in user-defined function is to always make sure that this user-defined function, when you're in the main program is used for entry and display. So in this one, we use it for declaration, entry, that is input, and display. But now for calculations, we use it in the main function. We use it in the user-defined function. So in this case, I want to say we can have int num1, comma, num2. Num2, then we can have the result, or maybe we can have addition. Now, if you look at this is anything that is declared inside the main function is a local variable. So this becomes the local variables. And because these are local variables, the value that I will enter in num1 will be passed here. Let's say maybe we use initialization. Num1 is equals to 4. Num2 is equals to 13. So in this case, 4, you will pass it in the function. 12, you will pass it in the in the parameter B, 4 will pass it in A. And now, for this case, we can get the result. So we have addition is equals to, addition is equals to the function name. But what I'm passing num1, comma, num2. num1, comma, num2. So please allow me to use these values. Remember here, we're not using programming code. If I use as a capital letter, understand that we are still using it as a small letter, but when you go to the coding, we cannot mix up these characters. So in this case, maybe I can first of all do away with this. Let me use it the way it is. I do away with this first. So in this case, we have defined a local variable num1 and num2. Num1 has been initialized to 4, and num2 has been initialized to 13. So in this case, I want now to display the calculation. And for you to display this calculation, now it must go back to the function. And when it goes back to the function, we will be able now to understand the presentation of this. So in this case, you can have printf, maybe we say percentage D, percent, comma, and then we have addition, percentage addition. So remember, this addition is in small letter. We have addition. So in this case, we can now return 0, comma, and then we close that program. So this program that we have written is not complete because we must have a function that we are supposed to use. We must have a function that we are supposed to use. So that's why we must now include the function. We must now include the function. And the function that we are supposed to include is that the one that we have already defined within the function prototype. Within the function prototype. And this is now the one that we copy. Just copy this the way it is, copy, and then we paste somewhere here. But remember here, we don't use a semicolon. Then we press enter, then we open that. Then after that, what we need to do here is now return A plus B. Return A plus B, and then we can close that. So in this case, if you look at this code that I have here, it's just an addition of a function that we are supposed to have. It's just an addition of a function that we are supposed to have, but it is a combination of what we are having within the main program. Meaning, num1 is 4, num2 is 13, but when it comes across and, which is now our function, it now passes num1 to A, num2 to B. The whole of this, we are now passing by value. We are passing by value. And I want us to write this program. We see whether it will give us the output that it is supposed to give in that. Let me try to copy that. And I go to the editor that we have here. And I'll try to copy that program here. So already I have copied the program. Let's try to see whether it will execute. We understand that 4 plus 13 is 17. Hint resolve errors. The issue is because I have copy pasted, I am using capitals, which is very wrong. So I must first of all confirm. So I have int. Then I confirm with the other one, int. Maybe I convert this. That was the problem because of copy pasting. Then I try to run this program. So main C in function main, function main. So main function, you open that. That should include this main function, percentage G, this is addition, printf, return 0. This, we open this, they should be small r, they should be small r. Because it contains an ASCII characters, combination of numbers. I don't know why. I don't know why. I don't know why. So int and int A, int B, int num2 addition, num1, num2 addition. Addition is equals to add. Let me introduce maybe and x. And x maybe, you see, and x, int b, int A, int B, return A plus B. So and x. I don't know the issue. When you're using this, maybe we still have to understand. I don't know. So the problem is printf percentage D. Printf, okay, percentage D. So I think percentage had an issue. Those are not quotes that are supposed to be used. Percentage D, we have an issue still. Let's see whether there is capital P. Yes, it is capital P. So that is the problem of copy pasting. Okay, so I think the problem is okay. Now you can see the output is 17. Can you see there's output? Maybe you can see the output. Can you see that output? Are we able to understand what we are saying, please? Are we able to understand what we are saying? Are we able to understand? Yes, so I have, maybe, can we respond to this, please? It's good we respond, so that we can move together. So please, you can tell me whether we are responding or we are getting. If you look at the question, if you look at the program that we have already gotten an answer. Suppose we fail to use this command that we are calling that. Let's try to execute. It will still have an, okay, it can execute. I don't know why it's executing in online, but if I try to code using def or code block, it refuses. But I would prefer, please, never ever write a program without this function prototype. So always to include that, even if it is executing. Please try to use that. Okay, Felix, Grace, I have an answer from Felix. So I think we are understanding now. Now, with this code that we have, maybe we can try to interpret using our notes here. We were saying return type function name parameter. And I think I have explained this. But return type is a function may return a value. The return type is data type of the value that function returns. So in this case, we are now returning something where a function is supposed to return. But if it is not supposed to return, I think I have explained to use the word void in the execution. Function name is the name of a function. Parameters, these are placeholders. When a function is invoked, they are supposed to be passed from one point to another. Then function body, automatically, you know, this is the function body that we have. This is what we are calling the function body, and this is another function body that you are supposed to have within the execution. So in this case, we have an example here, and this is a very simple example. And maybe the program itself says what? Given below is the source code for a function called bags. This function takes two parameters, num1, num2, and that. So I think for now you can be able to calculate, or you can be able to use a function within as a local variable, or we can use it as a global variable. And the moment we use it as a global variable, and I want to use some coding here. If I declare something here, I'm defining it as a global. Like now, if I say I have int addition, this int addition is declared as a global. It is declared as a global variable. So you can use it in the main function. I can use it in the other function. Like now here, let's see whether it see whether it will work, and then I try to delete that. So in this case, if I try to run this program, we do get still 17. Is it able to execute the code? We need to execute the code the way it is supposed to execute that program. So still it is executing. And if I try to do away with this program cannot execute, because we said we must use a variable that has been declared. Suppose when I come here and I introduce addition is equals to a plus b. Then here, instead of a plus b, I say I return addition. I return addition. So in this case, if I try to run this program is supposed to execute, because now the addition is used as a global variable. The addition is used as a global variable. Yes, so that is the answer. Remembering that now we have already introduced it as a global variable. So irrespective of where we use, even if I have another function somewhere here, it can still do that. It can still execute that program. And we'll be able to interpret that code very easily. So I think we are understanding, because that is the main area that we are supposed to understand when you come to functions. So I think you have past papers. Okay, Onyango, you have a question here. Why did you use X, addition X? It's not a must I use that. I was trying to resolve some issues. I can use and. I can still use and. When I use and, I change everywhere. So it's not a must. I was trying to resolve that, but I had seen that maybe the error would be there, but the error was on printf. So there is no issue with that. There is no issue with that. Have I answered your question, please, Onyango? Have I answered your question? Yes? Okay, so I think now we can, Hashim, maybe you can tell me whether we are together. Are you understanding? Hashim? Okay. So I think we are together. If everybody is understanding, I think we are together. And we can proceed. So please tell your friends, whoever is not coming or attending this class, we will have an issue. Because right now, we have started programming. We started programming the moment we are doing arrays. So at that point, I want to complete on functions. Then when you complete on functions, I will go back to arrays so that we can code. And that is the platform that I will be using, the online C compiler, so that we can be able to understand as we progress. And then after that, you can try to write your own program. Now, I want us maybe to come here and write a program. Maybe I can call it, I want to try and change this. Maybe a program that displays the maximum of two numbers. Maximum of two numbers. Which number is the maximum of the other? So if I have 20 and 50, which is the maximum number? So we did that using function. Remember, we are using function. Using functions. So in this case, at least now we can understand that there are variables that we have to declare here. And one variable that we are supposed to declare, allow me to use this code up to this point. I copy that. I will be copy pasting some codes, and I want to remove this completely. But this one is supposed to calculate the maximum of two values. So we are saying maybe we have int maximum. Int maximum, and it's the maximum of int value, which is given as maybe I can call it A, and I can call it R. That is the function prototype. Then from there, I now enter. So I can have int X, int Y, int result. Then, if you look at this, we are saying printf enter the values. So allow me to be very short in writing this. So scanf, then we have percentage %d, %d. We close that. And this is where we have ampersand x, comma, ampersand y. Then we close that. Then remember here we said we must pass value. And I'm sorry, I will not explain this. This is what you call the actual parameter. This is what you call the actual parameter, but this is where we have the formal parameters. Formal parameters. So actual parameters are passed. So in this case, we can now have an actual parameter, and we have the result. Or it's not a must I use this result. Not a must. For this case, I can say printf the max is equals to x and y. So this one will somehow complicate that. So let me use the result here so that we can have a very easy representation. So we have result is equals to maximum of x, y. So if I'm not using result on this, here I was supposed to say maximum of x and y. maximum of x and y, and then I close that. But because I have already used this result, so automatically I will pass the whole of this with result. Then I can return 0, then I end. So within here, I can now introduce our function. And when I introduce our function, we said we don't use a semicolon at the end. There is a function prototype, there is a function declaration, and the whole of this is function definition. So in this case, I want to return something. But before I return, I must test whether A is greater than R. And if it is not greater than R, you display the greater value. So we test if A is greater than R. If A is greater than R, what are we supposed to return? So return A. Else return R. Then we close that. Then after that, we close that. So if you look at this program that I have, and I want to copy it the way it is. So within this code that I'm having here, maybe we can try to code here, and I want to start from this point. And within this case, I want to still change the values that I had. Integer, it was not capital. For this case, I want to press enter. So we have int this. That one is still okay. This P is supposed to be small. This S is supposed to be small. I don't know whether these quotes will be an interference. That this quote will be an interference because I have copy pasted that this R is small, and then this P is still small. Then we have quotes, return is small, int is still small, if should be small in small letter, R should be in small letter, R should be in small letter. So if you look at what I have here, I have said if A is greater than R, return A. But if it is R which is greater, return R. Return R. Because we want to get those values. Let us try to execute this program. We pray God so that we will not have errors. And when you are coding a program and it doesn't have any error, that is not a good way. Okay, so again. It is taking long, but don't worry. Maybe we can come back after explaining. So that is why we are saying in function declaration, function tells the compiler about functioning and how to call a function. So how are you calling a function? But I think I have explained that very clearly. Calling a function, or creating a C program, you give definition of what the function has to do. To use a function, you have to call that function, perform the defined task. That's why we can see everything that we are doing it in a function. we are doing it in a function. And that is now either testing whether this function is able to execute those consts the way they are supposed to execute within that point. So I think maybe we can still wait for this because it's taking too long. Huh? We have some issues on this. I don't know whether it is an issue with the server. Please. So I think we have an issue with the server for this editor. I don't know why we have an issue. I don't know why we have an issue, but maybe with the time it will give us the answer. It will give us the answer. Okay. It has done away with my code. It has done away with my code, and that is very bad. That is very bad because I have to repeat it writing these. So we have P. It is tedious, but when you are writing on a code, it becomes easier. It's because we had copy pasted. Remember, when you are copy pasting, it becomes an issue. So I think we are following what I'm doing. And remember, this is not new because we had already done that. And what I'm trying to change here is to remove all the capital letters that we have, so that we can reduce errors that we have. So we make sure that this one has opened, this one has opened and closed, this one has opened and closed. So let's try to code. I hope maybe it will execute faster. There is an issue with the server, so please, you will be able to try that program at your own time and be able to understand how we are doing that, please. Try to write that program at your own time, please. So any question after that point? Is there any question? Is there any question? Maybe you can ask a question. I'm waiting for your questions, maybe, and maybe we. Do you have any question? Yes, Felix. Okay, so there is no question. Onyango has said no question. Felix has said no question. What about Hashim and Grace? Omodi? Hashim and Mina Grace? Rachel, are we together? Are we together? Okay, so majority have said there is no question. So if you have a question, maybe you can ask that. And maybe we can still proceed. So what we have looked at is coming up with formal parameters and actual parameters. And I think I have explained it. If a function is to use argument, it must declare variable that accept the values of argument. These variables are called formal parameters or functions, where they behave like other local variables inside a function. And I think I had explained this. We are using them inside a function. So these are the ones that we are calling them the formal parameters. These are the ones that we are calling the formal parameters. These are the ones that we are calling the formal parameter. Maybe we can try to so these ones. So these ones are the formal parameters that we have, and these ones are now the actual parameters that you are supposed to have within the program. So don't know why it's not working. Okay, I think you have understood on that. So if you look at the notes, there are two methods of calling a function. And one method of calling a function is call by value. I will not start call by reference today. I want us to have some codes that we can have in coding, so that now we can understand how I'm saying, why am I saying call by reference is mostly used. If you look at these two, and we want to call it by value. When you call by value, what we do, we are not, we are calling a value only, a value. So calling a value. And this one doesn't arouse what you call no read, write operation. No read, write operation. But when you call by reference, there is what you call variable. Call variable. So for this one, no overwriting of values. No overwriting. But for this case, we have overwriting. And when you pass this, we are passing variable. And there is what you call read stroke write. There is read stroke write. So if you look at those two things that we have already talked about, when you are calling by value, this code that we have already written here, the code that we have already written here, which is still executing, we are passing by value because we are passing the value on a given statement. We are not passing variable. So we are passing the value that is in a given variable. But when you pass a variable, it is easy for you to overwrite that. And that's why in this, we must use an ampersand on a variable. So if I'm using int a, remember I must use an ampersand a, comma, int and ampersand b. So that now this one can be referencing to that memory address that you have within the execution. So is there any question up to that point? Because I want now we go and do a quiz on what we have already covered. Is there any question? So can we move to the quiz? So I'm expecting all 7 students to do these exams, 6 of them. So please do it because it is still graded. And I said I require marks for NEC pass rate. So am I allowed to go to the quiz? You give me 2 minutes, I set it, so you do with those remaining minutes. Remember, we have about 26 minutes. So can we proceed? Can we go to quiz? Can we go to quiz? So Felix, okay, yes. Hashim, can we go to quiz? Modi, Felix. Omondi Felix, are we together? So are we together, Omondi Felix? Are we together? So can we move Rachel? I think I have an answer from Rachel. What about Joseph? So can we move to quiz? Okay, let's go to quiz. And thank you for listening.